Okay, so it is quarter 4, week 7, and we are going to talk about conditional probability. So, conditional probability is a subset of total probability, and it occurs when some condition must be met first. So, this is a pretty complex looking equation, but I'm going to write it in words that will make more sense. So the notation is this. It says the probability of some event A happening given event B has already occurred, okay? And so in order to find that mathematically, on the top, or the numerator, we find what's the probability when both of the events happen at the same time. So both events occur simultaneously. And then in the bottom, we don't want the total of all events. We want the probability of the B event, which is the given topic. So the total of the given topic. And in the problem, you'll see that word given. Typically, we're going to do these problems using a two-way frequency table. So let's look at the first example. We've got a table of grades, and the students are divided between males and females. And so we've got A's, B's, C's, D's, F's, total males, females, total A's. There's lots of numbers going on here. So let's look at what the question wants. It says, what is the probability of a male student given that they have failed? So the A comes first and the B. So on top, what we want to do is we want to find out when do they both occur at the same time. So you want to look at what topics you have. We've got male and that they failed, failures. Okay, and so we look at our table and we've got males here. And then failures are in the column up and down. And so wherever the two intersect, males and failures, right here, 7, that's the number that goes on top. The bottom is going to be the given total, and it's the topic that comes after it. So given that they failed, so what we want is total failures. So we're going to use the failure column, and we go to the total, which is 13. So this would be our probability. 7 out of 13 is the probability of a male student given that they failed. Using the same table, we're going to do a second question. This says, what is the probability of a female student given that they got a B? So on top, remember, we want to find the two topics and when they occur at the same time. So we're talking about females and earned a B. So female and B. So I'm going to circle all of the females. And then here's all of the B's, and they overlap at 9. So there's 9 females that also earned a B. On bottom is the total of the given topic. So given that they got a B. So we want to find the total number of students that earned B's. So here's B's. We go to total, and we've got 15. So on the practice that you submit, I would like you to leave your answers not reduced. So 9 over 15 is great for your student practice. And then on the quiz, you might see it not reduced, and you might also see it reduced. It just kind of depends on the question. So if we reduce, both of these numbers divide by 3. So 9 divided by 3 is 3. And 15 divided by 3 is 5. So you might see 3/5 because that is the same value as 9 over 15. But on your practice, leave your fractions not reduced. So if you make an error, I can figure out which number is incorrect. Okay? So let's try another example. So this one says, what is your favorite color? We've got girls, boys, and a lot of choices. So this says, if a student is randomly selected, and all of the questions will say that, what is the probability of choosing someone whose favorite color is pink, given that the student is a girl? So on top, we want to find the two topics when they occur together. So we want favorite color is pink, and given that the student is a girl. So those are our two topics. So let's look at pink and girls. And we've got 18. On bottom is the total of the given topic. So given that the student is a girl, so we want the total number of girls. So I go to girls and we find our total is 45. So once again, on your practice, leave your answer as 18 over 45. And on the quiz, it could be reduced. I think I have both versions available, just so you know. Both of these numbers divide by 3. So we would get 6 divided by 9. And that actually reduces more. That divides by 3 again. So we would get 6 divided by 3 is 2, and 9 divided by 3 is 3. So 2/3 is the completely reduced fraction. All right, let's try another one. So fun time preferences. Estimate the probability that a randomly selected student will prefer to play sports, given the student is a boy. So on top are two topics when they occur together. We've got sports and boy. And then the given topic goes on bottom. So given that the student is a boy, so we want the total number of boys. So sports and boys, they both overlap at 25. And the total number of boys is 45. So that's what you'll put on your practice. And then if we reduce that, both numbers divide by 5. So 25 divided by 5 and 45 divided by 5. Okay. And let's try another one. So what is the scariest animal according to this survey? So what is the probability that a randomly selected student will be a first grader, given that the student said snakes are the scariest animal? So in the numerator, the both topics are going to be first grade and snakes. And then the denominator is going to be the total number of the given topic. So given that the student said snakes, so the total that said snakes. So we've got first graders and snakes. So both overlap at 10. And the total number of snakes, we're going to go down, and that's 22. So if we reduce, both numbers divide by 2. So 10 divided by 2 and 22 divided by 2. So 5 out of 11.